His personality. I'm not even joking. I took discrete math with him. I wasn't a math major, I was a biochem major, and I just fell in love with it. He was such a good teacher. He was just so enthusiastic, you know, he taught everything like in a really intuitive way, I think. And so I just kind of kept taking classes with him.
Continue.
Just never stopped.
Please continue. I think the best way for them to do is just go and talk to faculty members. I mean, all of our faculty members will be more than happy to discuss math with any student who approaches them. And so the best thing is just go and talk to professors, ask them what they're doing. Because sometimes also I teach a course, but this is not what I do for a living, writing math. So you have to talk and ask. It's a personality thing. Some people like to work by themselves, like to work alone. I mean, it's perfectly fine. I like to work with other people because I think it's like any other human activity, it's kind of a social activity. So working with other people and exchanging ideas and being able to have fun together. I mean, we were just talking with Logan, I mentioned, and so we were talking about his daughter, we were talking about his family. So it makes, I don't know, it makes sense to be part of a community. I think we developed this culture of collaborating with grad students, undergrad students, previous students, other professors, and it's going great.
Yeah, so that one's really neat because it's a really like approachable project for students of really any background. So they don't really need, you know, that much like proof-based background to really jump into this project. So it's all about Cops and Robbers, which is a mathematical game, which it's really easy to grasp because a lot of it you can get a lot of intuition from pictures. You know, draw an in-by-in grid, and you can get a lot of intuition from it. And we're working with two undergrads. I think one of them is a TAM student.
3 undergrads.
3 undergrads. One of them is a TAM student, and the other 2 I think are actually engineering majors. Oh, it's been fantastic. They've been the best ones. Like high school students and TAM students are usually great in general to work with because they're always so motivated, you know, and they just have so much eagerness to learn more, and they really they get really excited about the projects really quickly. And it's great because you don't really have to like stay on top of them and like ask them, oh, maybe look at this at home, because they'll come back to you with a bunch of new ideas, you know, and they'll say, oh, I found this out, or I went home and I think I proved this. And it's really cool. I like working with them a lot. So our work is more in like topology of the real line, looking sort of at like sizes of sets, basically. We're looking at sort of a definition that's sort of analogous to like nowhere dense sets, but more of like a restricted version of that, using functions to determine the size of the holes in the sets instead of just, you know, arbitrary find a hole somewhere. You're restricting how big or small those holes can be, and then comparing the sets that pop out with different functions. This is what we're doing right now.
So they are part of the community. They are the future. So they have to. I mean, we want them to succeed. We want them to do better. We want them to talk to us. I mean, they are the most important aspect, in my opinion, the most important aspect of being here. I mean, so once they realize this, that they are the most important asset we have here, they should start doing something about it. And, you know, just talk to us. Like I said, everybody will be more than happy to talk to any grad students, I'm sure, without exceptions.